Hello everyone, welcome to this channel, the Merchant Construct-preneurs and Tutors. Today I'm here with another interesting topic which affects the life of a building, life of a structural engineer, life of a construction engineer, students alike. So it's just this topic talks about foundation. So we're looking at a particular type of foundation, that is the footing. You know there are the various type of foundation. We have for the shallow ones we have the strip foundation, you have the pad foundation, you have the raft foundation, we have then for the deep we have the pile foundation. So today we'll be looking at how to calculate the size of a footing, the foundation footing, that the pad foundation, just that footing itself. It's a beginner's guide. So just like a checklist of what to do when you are done with your design. So ever wondered how buildings stand tall without sinking? The secret lies beneath the footing. You can see the images, the footings there, right? So let's start with defining what a footing is. So it will guide us on what we are to expect and what a footing is. So what I have here, a footing is the base of a foundation that spreads the load of the structure, right, to the soil. So let me take it again. A footing is the base of a foundation that spreads the load of a structure to the soil below. If it is too small, you might not be able to carry the building, then the building will settle or crack, right? So look at the image, you can see the load transfer, how it is being done, load to the columns, to the footing, then to the soil. So that is the image of the load transfer. So that is what the footing does. It collects the load and then spreads it to the soil, right? So if you are using this type of foundation, that is the pad foundation, we need to know the reason why we are making use of it, right? So maybe the building is a small building, a bungalow, or maybe a story building, but you've done your soil test and you discover that a footing can actually work there. So the footing size is as important as building itself, right? So the footing size is set to satisfy the following conditions. Now, we want to ensure the structural stability of the building, of course. Second, to prevent settlement and failure, right? So the next one is to adapt to soil strength, and then the last is to ensure that the code complies with the code, right? Your local code. So we are going to look at the quick steps to calculate this footing size. There are different methods. We are going to just stick to this list so that it will be easier for us to remember, right? So the first on my list, you have to determine the column load from structural analysis, right? So we said a footing collects load from the building, is sent it down to the column, and then the column sends it to the base, that is the footing, and then the footing to the soil. So first you need to determine the column load that is coming on each footing from structural analysis. Then the second one is to conduct a soil test to get the soil safe bearing capacity of the soil, right? So we don't just assume that because this person has done something similar, let me just copy the same. So you need to confirm with a soil test that has the safe bearing capacity. So then you apply the formula for footing area, which is the load from the column divided by the soil bearing capacity or the safe bearing capacity, whichever case you use. After getting the footing area, then you choose a shape you want, whether you want a square shape or a rectangular shape. Then to get the dimension of each of them, a square, all sides are equal, so you just like the square root of the footing area. While for the rectangular footing, you have to try two dimensions that will give you the footing area, right? So let's take an example so that we're going to understand what the checklist or the steps in calculating the footing area. So we just have a small example. Just as I said, it's just like a checklist, a beginner's guide. When you get this, okay, this is the load coming, and they just want to check whether this thing is okay, whether the base is okay, or the footing is okay. You just have to run. So for example, we have assuming the following: the column load is 600 kilonewton, and the safe bearing capacity is 150 kilonewton per meter square. So to calculate the footing area, it is the column load divided by the soil bearing capacity, right? So we have it as 600 kilonewton divided by 150 kilonewton per meter square. So after dividing it, we have 4.0 square meter. That's the area of the footing size, 4 meters, right? So the second step from our checklist is to determine a suitable shape for the footing and dimensions. Now, the shape, we have two options: the square footing or the rectangular footing. Now, as we said, the square footing, all the sides are equal. So what we do to get that is the square root of the footing area, which is square root of 4. So we have 2. So 2 meters by 2 meters will work, or is what we give, or what we are going to use for our square footing. While for our rectangular footing, we have the two options. Try 2.5 meters by 1.6 or 2.85 by 1.4 meters, right? So the next thing now, in summary, so we've gotten that. So the dimensions, either 2 meter by 2 meter or 2.5 by 1.4, anyone works. So in summary, just to calculate the footing size, first get the total load from structural analysis of the building, right? You know the soil bearing capacity. Then you apply the formula to get the footing area, which is load divided by the soil bearing capacity. Then now you want to determine the footing area shape, whether you want it to be rectangular or you want it to be square, and then the possible dimensions, right? So this is just a very, very short example of how to make a small check. So when you are faced with checking each of these things on site, it's just a small check. So thank you very much for watching this video. I believe you gained value from this video. For more videos on construction processes, calculations, engineering, structural engineering, and everything that concerns engineering, this channel is your go-to channel, right? So please, you can recommend this video to beginners, especially students, professionals, and friends alike. So you can like, share, comment, and most importantly, subscribe to this channel, the Merchant, Construct-preneurs and Tutors. See you in my next video. Thank you very much.